No. There's only enough pumpkin pie for me. Pumpkin. Oh, okay. Well, then you won't like pumpkin pie then, if you don't eat pumpkin. Well, you know, there's chocolate pecan pie as well. See now. Okay, collisions now, if you can write this down. Got that, collisions? You don't want to write the title down?
No.
Oh, you did? Okay. So, come on, Brian, you ready? Collisions, yes? Yes. Collisions. What does this mean, collisions? Yeah, indeed. Okay. So collisions are just what you said. They're impact, crashing. And it's a special type. There's a special type of collision in physics which is between two masses and there's no external force acting on the system. Meaning it's like you have two balls which just roll together and collide. We're not looking at situations where you push things together. We're just looking at situations where they roll together and collide. Yeah. This is a special type of problem in physics. And to help us deal with this problem, we have something called the conservation of momentum. Now, if you remember, what did conservation of energy mean? Yeah, it's just balanced. It's constant. So what do you think conservation of momentum means? Momentum doesn't change, yeah. And what was the formula for momentum? mv. So conservation of momentum means during a collision, the momentum is conserved. As a formula, so the idea is if you have two masses, m1 going at u1 and m2 going at u2, and they collide, and afterwards maybe it's heading this way with v1 and this way with v2. The momentum here equals the momentum here. Yeah. So as a formula, you can get this. m1u1 plus m2u2 equals m1v1 plus m2v2. This is the conservation of momentum, where m1 is the mass of the first object, m2 is the mass of the second object, u1 is the initial velocity of the first, you get the idea, and so on, so on, and so on. Okay, so this is an important formula, very important. If you can write this formula down, please, and its name. Got this, Jerry? Yep. Of course, you don't need to write all this down. If you know what the M's and the U's and the V's are, you could draw a picture, like what I did here, if you want. Got this? Yeah? Okay. Not yet. I see two people writing. Now I see one person writing. It's Brian. No, we're not rushing you. Do you need time?
Yeah.
I got lots of time. I can drink my coffee. Go ahead. No problem. This coffee? No, from my office. I'm cheap. I'm cheap and I'm poor.
And you celebrate for Thanksgiving.
And I'm thankful. I'm thankful for you. You think I'm lying? I'd love to, but my calendar, it just wouldn't be possible. Anyways, you wouldn't like it because I live so far away. Oh, you'd be shocked.
Which one?
1 minute away.
Hey, 402.
That's so fun.
Griffith College, Dublin. I'll tell you how far. In kilometres. 71 kilometres. Yeah, I know, I told you.
You come here every day? Like,
This is where I live. This is where we are.
Yeah.
Dublin. Yeah, we're in Dublin. This is where I live.
Well, you drive 1 hour every day?
No, I take the train.
Oh my god.
Oh, 2 hours is even more.
No, that's the bus. Is that the bus or the train?
That's
The train.
But it's telling me to take buses. This is silly. No, what I do, I take the train from here, and it gets me to Houston train station. You know Houston train station? It's near the Liffey, on the west of the city. And then from there, I take the Lewis to the nearest Lewis stop here in Dolphin's Barn. Do you know down that way? No.
How many times? How long?
I take the 7:20. I take the 7:15 train, and I get here at 8:30. It's not too bad. It's not too bad. 7:15 train, and I'm here in the school at 8:30.
What make it like that?
6:50.
Wow.
6:50 and come out 15?
6:50, and I leave the house at 7.
How it can be possible?
Because I'm a boy, I require less time.
Is that Ireland?
Yes.
Yeah.
Well, I'm not that far away.
Yeah, that's awesome.
You were thinking 70 kilometres, he must be out of Ireland at that point. Yeah, I commute from France every morning. Alright. Now, broadly speaking, there are 2 types of collisions. So they are elastic and the other one inelastic. Now, do you know the difference between the types? So, if I say it's elastic collision, what does that mean? And inelastic?
It's bound.
Well, both do. What types do?
They move in opposite direction.
No, it's not necessarily to do with their direction. So, what we say is, if it's elastic collision, then no kinetic energy is lost to heat. But if it's inelastic, then some of the kinetic energy is converted into heat from the collision. So elastic and inelastic, you can know if it is elastic or inelastic if you can know if the kinetic energy was constant or reduced. Okay, so you need to write this exactly down, please.
Why? Why is it converted into another form of energy?
Yeah, normally, if you think about 2 things colliding, sometimes they get hot after the collision. This heat energy came from kinetic energy.
How about sound?
Or sound, yeah, or sound. Heat, sound, yeah. It depends on what's colliding. So I picture something like snooker balls probably get a lot of sound. Whereas, like, if you think about 2 cars or something that collide, it might be both heat and sound.
What about elastic? Like, why?
Elastic, you see, it's not really possible because some energy will be converted into heat or sound. But I suppose snooker balls would be close to being elastic, or close to being elastic, but it can't really have it exactly elastic. Not really possible. Okay. So now that we have the basic ideas, we can have a look at some examples. So in this one, a 1 kilogram trolley, like a little toy car, rolls towards a stationary trolley at a speed of 3. And so you have one at rest, and the other one rolls along and collides, and then they stick together and move away together. Okay, so one is at rest, the other one comes along, click, and they move away together. So we'll do this one together. If you can draw or write this down, what's happening, and then we'll calculate it together. So I think a picture would be useful here. So you'll need your calculator in a moment. We'll do it together here. Yeah, got that? Yeah, okay, let's have a look. So, how fast is this one going, the 1 kg?
3
This is going at 3, and it hits this guy, who is at rest, and this is 2 kg? Yeah. And then what happens is, afterwards, they click together.
They move together.
Yeah. This is 1 and this is 2, and they move away at x, we'll say, meters per second. So the first part is, what is the x? Before they click together, this momentum is 3 times 1, plus the other momentum is 0 times 2, and that should equal x times 3, because now they're 1 unit. Okay, so this is actually easy to calculate. What's the x here?
1.
It's 1 meter per second. Yeah. Okay, B.
I'm dying.
Yeah, that's okay. Okay. Once you get your physics finished first, that'd be great. What is the kinetic energy before the collision? So the kinetic energy at the beginning, before, that would be 1/2 1 3 squared plus 1/2 2 0 squared, which is 4.5 joules. Okay? The kinetic energy after the collision will be 1/2 m1 squared. That will be 1.5 joules. So, D, what was the change in kinetic energy? A loss of 3 joules. So if the kinetic energy is being lost, then it is elastic or inelastic? Then it is inelastic. Yeah? I'm going to add in a couple of more parts here, but if you can just write this down, I'll add in an extra part here. So I'm just going to add in 2 more parts here. E is what is the imparted impulse on each trolley. So, do you remember what the impulse is? The formula? Yes, and there's another formula for it. Yeah, so let's do the first trolley first, the 1 kilogram trolley. The 1 kilogram trolley. The impulse is the change in momentum, which is mv minus mu, which is mv minus u, which is m 1 minus 3. Oh, and what's the m? We actually know the m. 1 minus 3. minus 2 kilogram meters per second. And then for the second one, the impulse on the 2 kilogram trolley, same deal. 2, 1, minus 0. Now look what happened here. What is the difference and the only difference? The minus, yeah. So if I was to calculate the impulse in total, what do I get?
0.
But why does that make sense? Of course it's 0. Conservation of momentum. That the total change in the momentum must be 0 for the whole system. So it makes perfect sense that this is the minus of the other one. Makes perfect sense if you think about it. Okay, so I just added that extra part in at the end there, so if you can write this down as well. Does this work? Oh, Jerry, you didn't tell me that the projector was a little bit off the edge here. Can you turn it? A little? No, okay, I'll ask Brian, because I asked you last time. Brian, could you turn this a little to the left? Now, don't fall and die, please. Because if you do fall and die, I have a lot of paperwork to fill out, and it's very time consuming. Okay, next example? Yep. Let me just add that extra part in that I just did there. What is the imparted impulse to each trolley? Okay. Next now. Yeah, I don't like this one. I'm changing it. No, I did it the last 2 years, and each time I don't like it. I'm going to change it. I'm going to make up my own one better. Okay, so we'll have 2 masses. Let's see. We'll make this one. We'll make them both 2 kilograms. We'll keep it easy.
Wow.
Lee, be good. Don't be laughing at these pair of balls that are 2 kilograms each. Thanks, Lee. I don't get. What's so funny?
Yeah, I don't get
yeah,
it.
what's
funny about it?
Oh, she's so. Monica, please, you're lowering the tone of the class now. Come on. Right, so the first one here, we'll say this is 4 meters per second, and we'll say this one here, we'll make it 2 meters per second. And after the collision, they both move away, so we'll call this one here V1, and this one here V2. And the only thing I'll tell you as well is that half the kinetic energy is lost. Now I'll give you a minute to try, wasn't it? No, sorry, they're both 2 kilograms, and it's a 4 and a 2.
Yeah.
And I wanted to know what is their speeds after the collision. And the other thing I tell you is half the kinetic energy is lost.
How?
Half the kinetic energy is lost to heat. Okay. No, it's a 4. Oh, afterwards? Not necessarily. In fact, I think it'll be different speeds.
So we have to do that separately.
Oh, Sean, be good.
It has a file
Hmm?
for the result.
You have the result?
Yeah, but it's actually
So, it's okay. I don't mind.
um,
Okay, since you have a result?
one.
Okay.
What we only ask is that question.
The picture?
What's the question?
Find V1, V2.
Oh,
Did you find them?
yeah.
Good. What'd you get for V1?
We cancel all.
Oh, dang.
I made simultaneous.
Simultaneous and everything cancelled.
Yeah.
Dang.
Because I did both steps.
Alright, I better do it now. Jerry, what's your answer? We'll see if you're right.
I think
I thought you got an answer. Chrissy? Sean?
I can give you the very
Fine.
we equal we are
What? No.
we are equal circuit and we equal square equal 10.
So root 13 and root 10. Maybe. Seem a bit big.
What the heck? What have I done wrong?
You think you can get it?
I don't want to have it. It's hard to put the number.
Okay.
But it has roots.
Okay. Alright. If you really think you can get it. KJ, how are you doing with this one? You think you can get it? Oh, good. Chrissy, you look a bit lost.
Yeah, I think I'm wrong.
Okay. Brian?
What have
Maybe.
I done wrong?
We need to find the KE equal after it separates into two.
Yes.
Yeah, cancel.
Okay. It couldn't be taking this long now. Come on. Alright, literally 1 more minute. I'm going to start a clock of 60 seconds. Stopwatch. Did Christy just fall asleep there?
No, I'm thinking.
Oh, see.
Is it? The conservation momentum with kinetic energy.
Oh, I need the square.
Yes. Yes.
Yeah, I took all formula and put everything in it, but still don't match.
Mm.
One moment. I have
You only have 23 seconds left, and then I'm not waiting any longer. I'm going to do it. But if you tell me the answer, I can. B1 should be a minus, yeah? Seems reasonable. And B2?
No way.
Okay. Not waiting any longer. So, the kinetic energy before they collide is a half v squared plus a half v squared. Cancel, 20 joules. If half of it's lost, then the kinetic energy afterwards is 10 joules. So you have a half to v1 squared plus a half to v2 squared should equal 10. Cancel. v1 squared plus v2 squared equals 10. Now, conservation of momentum says m1u1 plus m2u2 equals m1v1 plus m2v2. Cancel. v1 plus v2 equals 6. v1 equals 6 minus v2. In there it goes.
I have already
Yes?
put that there.
No? What?
Yeah.
Oh, so it matters.
What? Oh yeah. Well, my v1 answer should be negative and my v2 answer will be positive. That's fine. No, you can use the minus. No, don't. We've had big conversations in the past about minuses, which you've missed. Don't worry about the minus. Trust me. You can trust me this time. Just watch. Trust me and watch. Thank you. So, if I put this in here, I get 6 minus v2 squared plus v2 squared equals 10. 36 minus 12v2 plus v2 squared plus v2 squared equals 10. Yeah? 2v2 squared minus 12v2 plus 26 equals 0. Right?
Yeah.
2v squared minus...
Yeah, and then divided by 2.
And then divided by 2. So v2 squared minus 6v2 plus 13 equals 0.
V equals 3.
Huh? 3?
Yeah. Not 3.
No. There's no factors here.
Then less than 0.
No. Is it?
Yeah.
That's
Just 36 is less than.
yes, it is.
Just this we can't calculate.
So there's no answer.
That's the reason why I don't calculate.
Good reason. Can I like whole thing square?
No. No.
Teacher, you can.
Bracket v plus u plus v square
Yeah.
equals 10. And then u plus v square will be 10.
No.
No?
So it has
No.
to be plus.
Teacher, we can
Yeah.
add we one v2. We one multiply v2.
I don't understand.
I'm one.
I got that formula.
But no, I've made a mistake. This quadratic doesn't have any answers.
But why is my calculator giving me 3?
B squared minus 4ac. 36 minus V plus V2. 6 minus V2.
Maybe that's enough, right?
So it doesn't have answers. That's sad. No, I'll just change it slightly. I'm sorry. I'll say that 75% of the kinetic energy is lost.
We have to redo.
No, I'll just change it in red pen. Watch. So what does this number become? If it was 20 here, and I say 75% is lost, what will this become? Be 5. So this here, 5. So this here, 5. So this here will be... Oh no, that's worse.
Yeah.
Sorry. I need to go smaller.
18?
That's a 25% loss.
18%.
Not 25.
No. 10%. That should be safe. Okay, so what's this now? No, 18.
18.
Oh,
Yeah.
Oh.
Yeah.
18.
So this one here, 18. This one here, 18. 36 minus 18, 18. So this one here, 9. Oh, that's actually nice. That's very nice. So here we get V2 minus 3 minus 3. I like. It works out very nicely if I use 10% loss. So what does V2 equal? 3. So what does V1 equal?
3.
Yeah, it has to be 3 as well. So in this case they both move away at 3. Yeah, so I've changed it, I'm sorry, 10% loss. Yeah? Yeah?
I mean, you don't have to focus on the number. We just use your method.
I know, but I like getting answers at the end. Makes me happy. Okay. I'll change this question now so it says 10% is lost. Ugh. As a result of the collision, a tenth of the kinetic energy is lost. Okay, continuing now. So, just for a couple of minutes, I think. What class have you got next?
Assessment star.
Oh, please, that's hardy. What room are you in?
B302.
Yeah.
It's very far.
And really far from here.
7.1 kilometers.
7.1. There's 2 here for you. Keep that. There's 2 here, pass that. 2 here. 2 here. Okay, does everyone in the front row have one?
Yes.
Okay, give that to Jerry. Or Andrew. This one.
So many homework.
What is this? It's a menu. What would you like for lunch? Here.
I have.
You have?
We have finished.